Let's see one more kind of this synchronization mechanism. Till now we have been seeing various kinds of synchronization mechanisms, right? And generally most of them are used in order to allow only one process to enter into critical section and all the others to block, right? Now let's see one more type of synchronization method, which is called as barrier. Okay, instead of explaining it like with process, let me take a metaphor and explain it. Let us say there are a group of friends, 3 or 4, let's say 3 friends. A group of 3 friends are there, and now they all want to watch a movie, right? And then what they'll do is they'll try to go to the movie theater, at the same time. It is, they don't want someone to go very early and then sit there and the others too late, come join them late. So what they'll do is they will try to assemble at some point. They'll say that let's all meet at that point and wait for everyone to come, right? And once everyone comes to that point, then everyone will simultaneously cross that point. That is called barrier. Barrier means all the processes will agree upon reaching some point, and once they reach that point and everyone reaches that point, then only everyone will move forward. Otherwise everyone will keep waiting at that barrier, right? Now that set of process can be anything, which means the set of process can be sometimes 3 or 4 or n, which means your friends, set of your friends, how many people will be there in group. Generally I think 4 5, right? 4 5 is the good number. Now if 4 people or 5 people, let's say 5 people all are in one group, and you all decided that you all have to go to movie, then maybe you will pick up a closest restaurant and you will see that let everyone meet there and we shall wait there for all the 5. Even if one person is missing, we'll sit there and wait, right? That is how barrier is implemented. And now barrier is a busy waiting solution, which means you are going to stay there and wait. You are not going to go and sleep. You are going to stay there and wait until everyone comes, right? So how can we implement it? So one implementation given is here. So it is asked in GATE 2006. Maybe you could read the question GATE 2006 paper. I don't have space to write the entire question. Anyway, I'll explain you the question and then the options given. We shall pick the options. Okay, you please read the question. Read the question if you find it somewhere. Anyway, I'm going to explain you. They are saying that this is the barrier construct, which means any process, every process is supposed to execute this, right? And then move forward, right? And in order to execute this, they are using a mutex S. S is a binary semaphore or mutex, right, on which P and V are performed. P means down and V is up. That I think you know. And then they are going to use some global variables. Global variables means how many processes have arrived. Processes have arrived means how many of your friends have arrived till that point, and then how many processes have left, which means after arriving that point, again one by one can leave, isn't it? So again that also is going to be maintained. So there are two global variables. One is process arrived and other is process left. And in order to protect the access to these global variables, we are going to use a mutex, which means only one process can access this variable at any time, and the mutex is P of S, that by the name S. Fine. Now if you have to understand this in the metaphor of your this group of friends, let me say, put it this way. Let us say you are all going to a playground and play cricket, and now that ground is having a wall, right? That is a barrier, and you all thought that we'll all go and stand there until the entire team gathers there. Once the entire team gathers there, we shall jump the wall and we can go and play. So now that wall is nothing but the barrier, isn't it? Everyone is going to go and get collected there until everyone else joins, right? Then how the problem is, whenever any person goes and goes to that wall, it is not that he will stand there and everyone else could see that he is there. So what he is trying to do is, whenever any person goes there, on the wall he is going to write the number 1, first person, and he will go and sit somewhere, right? And when the next person comes, he is going to increment it that, oh, I too came, which means 2, right? And then third person comes 3, 4, 5, 6. Let us say you have fixed up the number to be n or 11. 11 is your cricket team, right? And now once the number reaches 11, then everyone who sees it next will understand that, oh, all the 11 people have arrived, and anyone who who goes and see the number on the wall will try to jump the wall, right? Like that everyone will keep on jumping. But then while jumping the wall, they will maintain one more variable and they will say that I left. So process left equal to minus minus, which means from 11, if one process jumps the wall, he is going to make it as 10. If other process jumps the wall, he is going to make it as 9. Like that, it will keep on decrementing, right? So initially process left and process arrived, which means both will be 0 and 0. As and when a process approaches that wall, they are going to increment the count 1, 2, 3, so on 11. And as and when a process, as and when the number reaches 11, then we keep on, jumping, which means we keep on incrementing the variable process left, right? And when the process left becomes 11, then what does it mean? All the process have arrived and all the process have left. Then the last one to jump the wall, what he will do is, he will make both of them to 0, 0 and he will jump, because next time if they want to do the same procedure, they don't want to see the number 11 there, right? That is how this method is implemented. Just watch it here. Now any process which arrives is going to make process arrived plus plus, right? While process arrived is not equal to 3, they will busy wait. So this is a while loop with a semicolon, which means as long as number of process arrived is not equal to 3, they are going to fall in an infinite loop, which means they will continuously wait until the process arrived equal to 3, because here the question is they are working with on a group of 3 processes. That is what they said. They said that there are 3 processes and all these 3 processes are using the barrier, and no process should cross the barrier until 3 process arrives there. Got it? And for that, in order to synchronize the access to this global variable, they are using a mutex, yes, right? And next what happens is, see this, and once all the 3 processes have arrived there, right, then process arrived equal to 3 at some point, then each process will come out of this loop one by one, right? And let us say first process came out, then what it will do is, it will again access process left minus minus, which means you are now jumping the wall. Before jumping the wall, you are going to say that I left, which means process left equal to 1. It is 1 means one process left, and initially both are 0, 0, right? And then similarly everyone is going to jump one by one by incrementing it. The third process to jump the barrier is going to see that process left equal to 3, which means it is the last process. Therefore it is going to set process arrived equal to 0 as well as process left equal to 0 for the future purpose. Got it? Okay, understood this one now? Now there is a wall. Wall is nothing but the barrier. So everyone gets collected there and keep on incrementing the process arrived, and everyone will keep on jumping and keep on incrementing the process left. And the last one who is going to leave the process is going to reset everything, so that for the next time it will be useful to use it, right? Okay, I hope you understood this. And now they are saying that this is fine. They are saying that the implementation of the barrier is incorrect. That is what they declared. They have given you the answer too. They said that this is a failure, this will not work, right? And then they are asking you the reason why do you think that it will not work. So they given some options. Watch it. They are saying that barrier implementation is wrong due to the use of binary semaphores, which means they are asking that instead of using these binary semaphores, you could have used counting semaphores. I don't see any difference. Even if you use counting semaphores or binary semaphores, I think here the correct one is binary semaphore itself, because we don't need to we should not let more than one process access a shared variable at the same time, because there will be inconsistencies. So actually using the binary semaphores here is right. If you use counting semaphores, simultaneously many processes will try to access this process arrived, and there will be inconsistency there. That is not the option, right? Mutex is the correct approach there. Binary semaphores is the correct approach. And second, option B is saying that the barrier implementation may lead to a deadlock if 2 barrier invocations are used in immediate succession. What does it mean? They are saying that a set of 3 processes are using the barrier, and all the 3 processes are going to leave one after the other, and again immediately if they want to use the barrier, then there will be a problem. That is what they are saying. Now can you just observe it, how it is, how it could be true? Just think about it. What if I say that option B is the answer? It is true. Can you guess how it is possible? Watch it, I'll just tell you. See, now assume that process 1 has come, 2 has come, 3 has come, and therefore process arrived equal to 3. Therefore all the processes will try to jump one after the other. Okay, and now what is process arrived number here? What the process arrived value here is, now as of now this variable value is 3, right? And at this point when the process arrived number equal to 3, at this point first process has left, which means process left is equal to 1 now, here, this one, and so it is not going to do anything with this, and it left. And immediately after leaving it, what if it tries to access the barrier? Because they are saying that 2 successive invocations are going to be done, which means immediately after it leaves the first process, it is again going to come back and access the barrier. Then what happens? When it comes inside and access it, the process arrived number will be 4 now. Got it? And now assume that the next 2 processes are also leaving the barrier. Then what happens to this value? When the second one leaves, this value will be 2, and that one will leave. And when the third one leaves, this value will be 3, and therefore if process left equal to 3, which means if it is the last one to leave, it is supposed to reset the values. Then it is going to reset the values of both of them. Process arrived to 0 as well as process left equal to 0. Got it? And now first process has already come here and it is actually waiting here, and now the second process will come and third process will come, and they are going to increase the process arrived numbers to 1 first and then 2. First process will make it +1 and second process will make it +1, right? Therefore now the final value of process arrived will be equal to 2, even though 3 processes have arrived, and all of them are going to go and get stuck here in this while loop, because everyone is waiting for the process arrived to be equal to 3. But then when the first one has arrived, that count is lost, because you made from 3 to 4 and then you made it to 0. Are you understanding this? The problem arises here. Okay, let's go back to that wall and friends metaphor. Now let us say there are 11 players, right? And now what happened is, you are going to have a wall and all the 11 players are going to come there and say that I arrived, and whenever they jump the wall, they are going to increment the friends left variable by 1, and the last one who leaves it is going to reset the values of arrived and left to 0 and 0, right? And now what happened is, the 11 processes have arrived, 11 friends have arrived, and the first one jumped the wall, right? And again the first one came back to the wall, because he is done with the jumping, and again he wants to come because successive invocations, right? Again he came back, and now once he comes back, he is going to increment the arrived value by 1. Now that 11 value is actually changed to 12, right? The total arrived value has to be 11, but now it is showing 12. But then the processes left is just 1 as of now, because only one process jumped and one process came out, right? And now when all the remaining friends, they keep on jumping, the last one to jump at some point will make the left value, the process left value as 11. Now that last one is going to make this 12 value and this 11 value, 12 is arrived and left is 11, as 0 and 0, right? And even if all of them come back now, right, already the first one has incremented the arrived, and now he is not going to increment it again, but the remaining 10 people are going to increment it. Therefore even though 11 processes have again collected at the wall, 11 friends have arrived at the wall will show that arrived friends is equal to 10, right? Because of which everyone will keep on waiting for one more, which means even though there are 11 friends there, everyone will think that there are only 10 friends, and all these 11 friends will wait for the one more friend who has to come, because the count is showing as 10. Understood this? Right? If you didn't understand it, watch it. What I am trying to say is, now all the process have arrived and all the process have left, and the first process which left the barrier again came back, and it should have come after this process arrived has become 0, right? But then when the process arrived is still 3, it is trying to increment it and make it 4, which means one count is actually lost there. Why? The last one to leave the barrier is going to make it as 0. Got it? And therefore even though one process is in the while loop, right, here you will show the wrong value as process arrived equal to 0, and then later 2 processes will come and still they are going to make process arrived as 2, which is supposed to be 3. Therefore the set of 3 processes are waiting for the arrived variable to become 3, whose value could be just 2 in this case, right? Therefore it is going to fail because of this. The barrier implementation may lead to a deadlock if two barrier invocations are used in immediate succession. Note the value, note the word may, which means it is not true always, only sometimes, right? Okay.